Hey everyone, in this video we're going to be taking a look at simplifying expressions to solve equations. So this is really an extension of the last video that I did, which was an introduction to solving equations. I'll put a link in the description below, so if you haven't seen that one, go ahead and check that out. But for now, I have 6 examples over here on the left side, and at any time during the video you could click on these yellow links here and it'll take you to that portion of the video. So we're going to go through these 6 problems here, and we're going to try to create equations out of these and solve them, with the exception of number 3 and 4. 3 and 4 is really preparation for numbers 5 and 6. For 3 and 4, the directions I have written here is simply to simplify these 2 problems. So let's move on to number 1. I have number 1, it's a rate, distance, and time problem. Okay, so we have 2 trains. They are leaving the station going in opposite directions. One train is going 60 miles per hour, while the other train is going 80 miles per hour. How long until the trains are 50 miles apart? Well, okay, so you may want to go ahead and read this a few times and write down the important information that we have. In problems like these two, it's important to recognize what type of information we're dealing with here. So obviously on the left I wrote rate, distance, and time. That's the information that we're dealing with. So you want to think, do you know an equation that may relate rate, distance, and time? And at this point, I hope you do. The rate is equal to distance divided by time. So this is an average rate. Something goes a distance in a certain amount of time, we're going to get the average rate of that object. So that's the relationship we have between the rate, distance, and time. Okay. Now, you may want to draw a picture. So, let's say we have our station here. Here's the train station. We have one train going one direction, and we have the other train going in the opposite direction. Okay, so one train is going a little bit faster than the other. We have one train going 80 miles per hour, so 80 mph, and we have the other train going 60 miles per hour. Okay, so this is a good start. So the question is asking how long until the trains are going to be 50 miles apart. Okay, well, let me call this train 1, the one that's going 80 miles per hour, and let me call the one that's going 60 miles per hour train 2. So if train 1 is going 80 miles per hour, it's going to cover a certain amount of distance, right? Now, what's the distance that it covers in a certain amount of time? Well, if I go over to my rate is equal to distance over time, I could figure out the distance here, d. Okay? So instead of having this equation solved for r, let's take this equation and let's solve it for d. So I'm going to begin with my equation. R is d over t. Now if I want to solve for d, I need to move the t to the other side. So I do that by multiplying by t on the right side, and I balance the equation by doing the same thing on the right. So now we have a new relationship. We have that d is equal to rate times time. Okay? So the distance, I'm going to do d sub 1 for the distance that train 1 traveled. It's going to be its speed, which is 80 miles per hour, times the time it was traveling. Okay? And what about the distance that train 2 covers? Well, the distance train 2 covers is equal to its speed, which is 60 miles per hour, times the time that it's traveling. Okay? Now, we want these two distances, d1 plus d2, we want it to equal 50, right? The distance the first train travels plus the distance the second train traveled is going to be the total distance between these two trains, right? So d1 plus d2 should be 50. And now we're going to replace d1. We know that after a certain amount of time t, the distance it went is 80 times t. So I'm making a substitution. Instead of writing d1, I'm going to write 80 times t. And then we have a plus. But instead of writing d2, I'm going to write 60 times t. So I'm making that substitution there. And I want this to equal 50 miles, right? This represents a distance here. Okay, this is a distance. And this represents a distance here. And the addition of those distances should be 50. Okay? So the setup for this particular question, it's a little bit difficult. It's a little tricky. But once you start playing around with the distance, rate, and time problem, then we get to this portion here. And then we get to this portion right here. Okay? And now, taking a look at the question too, the question wants to know how long, right? It's asking for a time. You always want to keep in mind what the question is asking for. And in this case, when it asks how long, we're referring to the time. Okay? And that is our missing variable here. If you notice, we have these t values that represent time. So to solve this equation now, we want to go ahead and combine like terms when we can. So 80t plus 60t, we're going to get 140t. And this is equal to 50. And division by 140 on both sides will give us the t value. So we get t is equal to 50 over 140, which we can reduce. 10 goes into both of these, so we're going to get 5 over 14. And if you can if you can reduce, you always want to reduce. And what are the units here that we're dealing with? Well, we were dealing with miles per hour for the speeds, right? Our distances were measured in miles, and our time is measured in hours. So the units here should be hours. So 5/14 of an hour. Okay, so that's problem number 1. And 5/14 hours could be converted into minutes if you'd like, but there's no particular need to do that in this question. But if you're curious about how long this actually is in minutes, you could go ahead and convert that. So moving on to number 2, I wrote down fixed and variable costs here. This is what we're dealing with in number 2. We have 2 phone companies. Phone company A charges a fixed rate of $30 plus 5 cents per minute that you're talking on the phone. Phone company B, they have a different contract. They're just going to charge you for 100 minutes, and then on top of that, they're going to charge an additional 8 cents per minute. So they're just adding 100 minutes to your contract automatically. That's essentially their fixed rate. And the question is, how many minutes on the phone will yield an equal bill from both companies? Okay. So the total cost, you may remember this, we have the total cost is equal to a fixed cost plus a variable cost. Okay. So this is what we're dealing with here. Just like in the previous problem, we're dealing with rate, distance, and time. In this problem, we're dealing with the fixed cost and variable cost. We may have a fixed cost, we may not. We may have a variable one, we may not. So let's see. Let's talk about phone company A. Let me call the total cost of phone company A T sub A. So the fixed cost, well, the problem tells us that they charge $30. So that's going to be our fixed cost. And plus, now we have a variable cost. For every minute we're on the phone, they're going to charge us an additional 5 cents. So, 5 cents we need to convert into dollars. Be careful of that. We don't want to write 5 times how many minutes we're on the phone, because then, you know, if we're on the phone for 1 minute, the total cost is $35. No, that's not right. So we want to convert that 5 cents into dollars, which would be 0.05. And then we multiply this by M, okay, because for every minute we're on the phone, we're being charged 5 cents. So that looks like a good equation for the total cost of phone company A. So depending upon the number of minutes you're on the phone, you're going to be charged a certain amount of money. And for phone company B, let's call that T sub B, the total cost for B. Well, this is going to equal, now do they have a fixed cost? Well, they sort of have a fixed cost. It's kind of built in, but let's ignore the fixed cost for now. Let's talk about a variable cost. Let's see. So they're going to charge 8 cents per minute on the phone. Okay, so just like in this problem here, we're working in dollars, so when we see 8 cents, we want to convert this to 0.08. Now, I'm going to open up a set of parentheses, and I'll show you why here. This is 8 cents per minute, right? So we're going to have an M here. So 8 cents times the number of minutes. However, they automatically add 100 minutes to my phone bill. Okay? So this is going to be M plus 100 in parentheses. So if I'm on the phone for 2 minutes, then they're going to charge me for 102 minutes, right? If I'm on the phone for 100 minutes, they're going to be charging me 200 minutes. Okay, so that's where this M plus 100 comes in, because they're adding in an additional 100 minutes, no matter if I actually talk on the phone or not. Okay, so this is going to be the bill here. Another way to think about it is the 100 minutes is essentially a fixed cost. 100 minutes times 8 cents per minute would be $8. So you could think about their fixed cost as being $8, and then the variable cost as being 0.08 times M. Okay, so essentially phone company B, the fixed cost is less than phone company A. However, to talk on the phone, it's a little bit more expensive. And with phone company A, it's a little bit higher fixed cost, but it costs less to talk on the phone. So we want to find out, the question is asking how many minutes on the phone will yield an equal bill from both companies. Well, T sub A is the first bill and T sub B is the second bill. I want these to be equal. So what we're saying is that 30 plus 0.05 M should be equal to 0.08 times M plus 100. Okay, so here's our equation. So this looks good. We have a missing variable m. Okay, that's what we're looking for. So let's try to solve for m here. Let's see what we have to do. Now, we want to simplify combine like terms whenever possible, and distributing is also a big thing. If you could distribute, you most likely want to do that to break down sets of parentheses. So over on the left side of the equation, it doesn't look like I could do too much at this point. These are not like terms, so I cannot combine those. However, over on the right side, we can distribute this 0.08 to both pieces in the parentheses, and we obtain 0.08m plus, now 0.08 times 100 is just 8. Okay, so now another tip that I mentioned in the last video is in these simple equations here, we want to try to move all the variables to one side and all the constants to the other side. So we are going to, let's move all the variables to the right. Let's move all the constants to the left. So let me begin with this 8. I want to go ahead and subtract 8 from the right side, and I want to do the same on the left. So on the left side, we're going to get 22 plus 0.05m is equal to 0.08m. Okay, this 8 is no longer here because I subtracted an 8, so those are canceled out. And now I want to subtract my 0.05m from both sides. So we're going to get 22 is equal to 0.03m. Okay. And now 0.03m is equal to 22. So the last step is, when we're trying to solve these equations, when we want to solve for m, right, how many minutes? So how many minutes is what we're looking for? We're looking for m. We want to obtain an expression or an equation that looks like this. M is equal to something. Right now the 0.03 is in the way. So we have to go ahead and divide both sides by 0.03. So, and you know what? Here, let me do this. So we're dividing the whole right side by 0.03 and the whole left side by 0.03. So m is equal to 22 divided by 0.03. Okay, and you can do this division here, 22 divided by 0.03. It's like multiplying 22 by 33 1/3. Well, let's see. So if I want to do this division here, what are we going to get? So we get 22 divided by, now 0.03 is 3 over 100. Okay, so 22 divided by this fraction here. Instead of dividing by a fraction, I want to multiply by a reciprocal. So this is 22 times 100 over 3. And that's equal to 2200 divided by 3. And so this is a fraction form here. Okay, 2200 over 3. Now it looks like we're going to get 733.3. So 733.3, yeah. Okay, so this fraction is approximately 733.333. And the units on there our minutes. Okay. So 3 doesn't go exactly into 2200. You can see that the digits here, 2 and 2, add up to 4. And if that sum is divisible by 3, then we're going to see the whole number divisible by 3. But that's not the case here. So we're going to get this for an answer if you were to do this on the calculator. And we don't want to forget the units too. We're dealing with minutes, right? We're dealing with minutes the whole way through. Okay, so that's number 2. To set, so we had to first, get a grasp on what was going on, and then we had to set these costs equal to each other, and then from there we were able to solve for the minutes. Okay, and so what this means is if you're on the phone for this amount of time, then your phone, it doesn't matter which phone company you have, the cost is going to be the same. Okay. So moving on to number 3. Now number 3 and 4 are not equation solving. We just want to simplify. And it's really important to know the difference between just simplification and equation solving. So with equation solving, what we have is an expression equal to another expression, and we're trying to solve for some missing variable in there. So we follow the basic principles of equation solving and those examples. But when the directions just say to simplify, okay, most likely what we're dealing with is an expression. This is just an expression. We don't have any equal sign, right? So we're not following the basic principles of equation solving. We're just trying to combine like terms and distribute wherever possible. Okay, so when it says to simplify, we just wanted to clean this up and try to make a simpler looking statement. So for example here, we could distribute this 8 to both pieces. So we're going to get 24x minus 32. And then let me rewrite this here. We're going to have minus 2x plus 9 minus 6x. Okay, so now we want to try to combine like terms wherever possible. This 24x, negative 6x, and negative 2x, those are all like terms. And then negative 32, let me do double underline, and the positive 9, those are like terms. So we want to combine all those. So 24x minus 2x would be 22, and then 22x minus 6x would be 16x. Okay, so those are all the x terms, and then our constant numbers, negative 32 and positive 9, we're going to end up with a negative 23. So this expression here simplifies to 16x minus 23. Now the reason we want to know how to simplify this, first of all, it's a good exercise to understand what the directions are telling you to do. It's also going to be beneficial when we go to solve problems like number 5, where we have to simplify, maybe work with one side at a time and simplify this before we try to solve the equation. So let's take a look at number 4. Number 4 is similar. We want to simplify 3 times x plus 2 minus x minus 1 and plus 5. Okay, so the idea is the same. You want to distribute where you can. So we have that distribution. We could also distribute this negative sign to these pieces in the parentheses. So we're going to have 3x plus 6. Right, that's 3 times x, and then 3 times the 2. It was 3x plus 6. And then over here, we have a minus sign out in front, or a negation of this set of parentheses. So the negation distributes just like the 3 does. We have negative x, and then negative 1 would be positive 1, and then plus 5. Okay, so whenever you have something to distribute, go ahead and do it, so you could break down those parentheses and then combine like terms right after. So now we want to combine like terms. We see we have a 3x and a negative x. That would make 2x. And then we have a positive 6, a positive 1, and a positive 5. Those add up to 12. Okay, so this simplifies to 2x plus 12. Okay, so now let's go ahead and put that simplification to practice with, now keep in mind we're trying to solve now. Okay, so now we have an equation. We have an expression here equal to another expression here. That's the definition of an equation. Okay, and we want to solve for x. All right, well, before we attempt to solve for x, we want to try to simplify both sides. You know, could you do anything on the left side to make it simpler? And can you do anything on the right side to make it simpler? Well, we just talked about the distribution, so that would be a good idea here. We're going to have 2 times 9 and 2 times x on the left side. So we're going to get 18 plus 2x. Now we have equals. And over on the right side, you know, could we distribute the 4 and could we distribute the negative? We certainly could. So 4 times 2x and 4 times 1, we're going to get 8x plus 4. Okay, that's this piece here. And then we have a negation of 7 and a negation of negative x. So we should get negative 7. And negative x would be a positive x. Okay. So that distribution allows us to break down those parentheses, and that's going to allow us to combine like terms. So over on the left side, could we combine like terms? Well, no, those are not like terms. So those have to stay separate for now. And over on the right side, we do have some like terms. We have an 8x and a positive x. So we're going to get 9x. And then we have a positive 4 and a negative 7, so we should get negative 3. Now at this point, when you can no longer work on an individual side, now's the time to start applying the principles of problem solving. Okay, so one of the ideas was to move all the variables to one side and all the constants to the other side. Okay, that usually helps in these linear equations. So let me move all the variables to the right. So I'm going to subtract the 2x here. I'm doing the opposite here, subtracting 2x, so they're going to be gone. And over on the left, we'll be left with an 18. And on the right, we'll end up with a 7x minus 3. And I wanted to move all my constants to the left. Now, it doesn't matter which side you move things to. We're going to get the same answer. There's a few different ways to go about it here. So don't worry if you did this problem a little bit different, as long as we get to the same solution. I mean, that's really the goal here. So we're going to add 3 to the right, and we're going to add 3 to the left, right? Because we have to do the same thing on both sides to obtain a valid equation. So we get 21 is equal to 7x. And lastly, when we solve for x, keep in mind we're trying to get x is equal to something. So what's the problem here, right? Is it 21 or is it 7? Well, we want to get rid of the 7 here. So we apply the inverse operation of multiplication, which is division here. So 7 divided by 7 is a 1. And we balance the equation by doing the same thing on the left. We get 3 is equal to 1x, or just x. Okay, and that's our solution here. Now, I do like to check answers usually. Like if we get x is equal to 3, we could plug it back into the original equation and see if we get a true statement. Okay, so this would be 2 times 9 plus 3 is equal to 4 times 2, and that's times 3, plus 1. So there's lots of parentheses going on over here, right? And then minus 7 minus 3. Okay, Well, over on the left side, following the order of operations, we would do 9 plus 3 to get 12, 12 times 2 to get 24. And over on the right, let's see. So inside this set of parentheses here, we're going to get 2 times 3 is 6, plus 1 is 7, and 4 times 7 is 28. And then we're minusing 7 minus 3 in parentheses is 4. And this is certainly true, right? 24 is equal to 28 minus 4. So 24 is equal to 24. So we know our solution is certainly valid. We get a valid statement. When x is 3, we see that these two expressions are equal to each other. So we know this is the right answer. Now moving on to the last example here, we have number 6. So it's another word problem, and I wrote perimeters here because we're dealing with perimeters of these shapes here. So we have a rectangle, and let me underline this. We want to know what we're dealing with here. So we have a rectangle, and it has a length that is 3 times its width. Okay, so let me underline that. That seems like an important piece of information. And then we have an equilateral triangle, so that's important. And this equilateral triangle has sides that are 10 more than the width of the rectangle. Okay, so the perimeters of these figures are equal. So find W, so find the width. Okay, that's what they're asking for. Okay, so when doing this problem, and when doing a lot of word problems, if it's possible to draw some type of diagram or a picture or graph that's going to help you, you should really do so. So we have, first of all, we have a rectangle. So let's go ahead and draw a rectangle. Okay, so there's my rectangle. Now, we're going to call this W, right? That's the width of the rectangle. And then these longer sides here would be the length of the rectangle. And we know that the length is 3 times the width. So this literally translates to be length. I like to do cursive L for length. And when you see the word is, this translates directly to an equal sign. So length is, and then 3 times the width. Well, that's not too bad, right? 3 times W. So these sides, I know, are 3W. Okay, so there's my rectangle. Next up, we have an equilateral triangle. Okay, so we need to know what an equilateral triangle is. An equilateral triangle means you have a triangle where all the sides are the same length. Okay, so I'm going to do the best I can for drawing an equilateral triangle. Okay, that looks pretty good. So there's my triangle. Now, what about the sides of this triangle here? Okay, what do they tell us? So these sides are 10 more than the width. Okay. So we have the width being W, and 10 more than the width would be W plus 10, right? 10 more than the width. Okay. And since it's an equilateral triangle, all these sides are going to be the same. Okay. So there are my two pictures, my rectangle and my equilateral triangle. And now we know that the perimeters of these figures are equal. So the perimeter of my rectangle, I'm going to call it P sub R, would be all the sides added together, right? So W plus 3W plus W plus 3W. And if I wanted to simplify this, we have how many W's? Well, 8. 1, 3, 1, and 3, we get 8. W. Okay, and how about the perimeter of my triangle? Well, this is W plus 10. It doesn't matter what figure you're dealing with. The perimeter is just the outside edges added up. So W plus 10 plus W plus 10 plus W plus 10. Okay, those are the three sides added together. And, and when we do this, we try to combine like terms, so we have 3W, and then 10, 10, and 10 is 30. So we get 3W plus 30. And now, with this information here, we know that the perimeters are equal to each other. So we know that 8W should equal 3W plus 30. Okay, so essentially what we did was we simplified one side of the equation, and then we simplified the other side, and then I put them into the actual equation. Okay, that's essentially what we are doing with number 5 here. We're simplifying first, and then we're going to go about solving this now. So we know these are equal to each other, so we could use the basic principles of problem solving. Now, could we simplify the left and right? Well, we already did that by doing this here. So now we just need to combine like terms by moving things to the appropriate side. So let me move all my variables to the left side here. Okay, so the left side will now become 5W, and the right side will just be 30. Okay, because I subtracted 3W from both sides. So now we have this valid statement. And lastly, we just want W, right? We're trying to find W. So we're going to go ahead and divide both sides by 5. And again, I want to stress that what I'm doing here is dividing the entire left side by 5 and the entire right side by 5. Okay, this is an important concept, and sometimes if this is not understood, it could lead to mistakes in the future. So what we get on the left here is just W, and 30 over 5 is 6. Okay, so we get W is equal to 6. Now we're not dealing with any units in this case here, but if we did have units, we would want to be sure to add them in this case. And so, does this answer make sense? W is 6? Well, if W is 6, the perimeter of the rectangle is 48, right? 8W. If you add this up with W being 6, you'll get 48. And for the triangle here, we get 16, 16, and 16. That equals 48. So the perimeters of these figures are 48. Now, it didn't ask us to find the perimeters of the figures. However, it very well could have, because once we find W, then it is possible to find the perimeters of the figure. Okay, so that's going to do it for this video, simplifying expressions to solve equations. Hope you enjoyed it, and I'll see you in the next one.